Hi, everybody. My name is Laurie Voss, and this is my first YouTube video. It's a slightly modified version of a talk that I gave to the staff of sf.gov about MCP. I thought it might be more generally useful, so I'm putting it up here. So, hello, a quick introduction. I've been in tech for 29 years now. In the past, I had been a web developer. I'm currently a developer relations leader. And in between, I co-founded NPM Inc. So I used to talk about JavaScript a lot, and now I talk about AI a lot because I got very excited about AI. Today, I'm talking about MCP, Model Context Protocol. I'm going to talk about what it is at the protocol level, but also at the philosophical level, why you should bother with it. And if you are persuaded that you should bother with it, how you can go about doing that effectively. So let's start with the basics. What is MCP exactly? It is a protocol for giving AI agents tools to get information and take action. But before we get into that, let's get into some more basic vocabulary. First, what is a model? A model is an LLM. An LLM is an extremely fancy form of autocomplete that, when scaled up enormously, begins to resemble human reasoning in a way that is frankly spooky. LLMs are computers that understand natural language, and that is a huge leap forward from traditional computers where everything had to be translated into code. What is an agent? An agent is a term overused in the AI industry to the point of being nearly meaningless. But when I use it, what I mean is it's an LLM that has been given a goal and a set of tools. The LLM figures out how to use the tools to achieve the goal without being explicitly told every step of how to get there. That is also a huge leap forward from traditional programming, where every step and edge case had to be specified. Context is everything an agent needs to know to get this job done. So it includes the goal, it includes any hints you might feel that you feel might be useful, and it includes the list of tools and how to call them and what to do when you're done calling them. So MCP is a protocol for giving context to agents. It specifies both how the tools should be made available and, crucially, how the agent should authenticate to the tools. The actual tool calling is actually the simple part of the protocol. By far, the more complex portion is how they got OAuth to work, because that turns out to be a critical part of the flow. This is not just how do I call this API, but how do I get permission to call this API, both from the user who is guiding the agent and the entity that is providing the server. Because agents can do things, they don't just gather information. So you have to be crystal clear about what you're giving them permission to do so that there are no unpleasant surprises. The OAuth part is important to know about, so let's run through it very quickly. Your client makes a request to the MCP endpoint, and we'll talk about how it finds the MCP endpoint later. It then gets redirected to a well-known endpoint which contains details as a JSON file of how to authenticate with OAuth, including a pointer to the OAuth server. The OAuth server might be external, something like GitHub or Google, that people routinely use to authenticate. It then makes a request to the OAuth provider, who provides the user the ability to allow or deny access. And then, if it is allowed access, it returns a token to the client, which can then make authorized requests to the server. With authentication very briefly out of the way, the actual protocol is streaming JSON over HTTP. It is very simple. It looks exactly like this. It's a JSON description of what tools are available and what parameters they take, and a human readable description of those parameters. That is extremely important because it allows the MCP server, the MCP client, to call the tool without consulting any further documentation. The tool description is enough to get started. Given the JSON description of what tools are available, your client can then make MCP requests, which can look as simple as this. This is just basically filling out the fields that the tool said existed. And the response from the server is similarly simple. Note again that this response is contained in a JSON wrapper, but it is fundamentally a human readable thing. That's a very important aspect of MCP because MCP is not just a protocol. MCP is also a new way of approaching a problem, and that problem is getting computers to gather information and take actions. It is an API, but it is also a step beyond APIs. APIs provide a mechanism to take actions and fetch information, but fundamentally, they expect to be used by a human. And that human is expected to be reading documentation about what those endpoints do and how they work and how you are expected to call them. APIs are primitives. MCP does not work that way. MCP tools are task-based. They are not, here are some objects, figure out how to use them to complete your task. They are more like, here are some tasks you might want to perform, and here's how to perform them. The documentation is built in. Humans are not expected to figure out how MCP tools work. Your agent is expected to figure that out by itself. Of course, agents might not understand at the first try just from reading tool names and descriptions what a tool is and how to use it. But one of the magical things about agents is that they can self-correct. An agent that makes a tool call and gets a response it doesn't understand doesn't have to error out. It can think about it and try again. The best agents make a note of how they failed and they add that to their context so they know how to make better calls in future. They augment their context with a list of previous failures so that they don't repeat their failures. Which brings us to another important aspect of MCP, which is that the MCP server, the MCP tool, can also be another agent. In fact, in a good MCP server, it is almost guaranteed to be, because the client agent is going to be making requests, and the service job is to look at those requests and figure out how to satisfy them. It can respond with basic API errors, of course, but it can also respond in natural language. It looks like you're trying to perform this task, but you didn't get it quite right. I need this information. So it's best not to think of an MCP server as an API surface. It's best to think of it as a robot that knows about your API and can use your API under the hood. It can receive formal requests or maybe natural language requests from agents, and it has the context you gave it about how your API works and how to string your API calls together to achieve tasks. Depending on your perspective, this sounds very exciting or like a total nightmare, and in reality, it's both. If your MCP server is itself AI, you've suddenly unleashed an agent in your organization, and agents have a whole new set of security concerns. They provide an entirely new attack surface. Instead of regular true-false API boundaries, AI agents can be tricked by somebody talking fancy. This makes MCP an expensive proposition. If you do more than wrap your API, which you should definitely do, then you have to think about what your tasks are and who your users are and what journeys they are on. That's a whole new design cycle, and those are expensive. To say nothing of wrapping an LLM and making API calls, which are also expensive. And of course, in addition to all of those things, MCP is also a protocol. It also has the drawbacks of introducing a new protocol. The standard is still in the process of rapid evolution. There are bugs, there are security concerns, there are frequent updates, and there are non-compliant clients who might be using an older version of the protocol that you have to figure out how to satisfy anyway. So it's a bunch of work, but it's work that I argue is worthwhile because of what else MCP is. MCP is a big step forward in getting computers to be able to talk to each other and figure out how to solve your problems. It allows you to skip tutorials. You can skip setup steps. You can skip authentication. You don't have to give your users all of those things. You can jump straight to problem solving. You can encapsulate entire workflows as tools and provide them to agents to handle tasks. And what that does is enable vibe coding. I have mentioned vibe coding now. It is a controversial topic. It's a very divisive topic, but I'm here to argue that vibe coding is an unfortunate name for an excellent trend. Call it AI-assisted coding if you prefer. We, by which I mean human society, have been trying to democratize access to information for a long ass time, easily for thousands of years, ever since we invented writing things down. Things picked up steam when we invented the printing press and hit a whole new level with the advent of the internet. People who are better informed make better decisions, and people who make better decisions have better lives. It is a simple principle, very basic, with which I hope you are all on board. Since the internet came around, our efforts to democratize access to information have really stepped up. We slapped everything we knew into text and put it online. Then we threw databases up there too. Then we created APIs to those databases. There are whole programming languages, frameworks, APIs, and apps that have been thrown at this problem of getting people better informed and making better decisions. Software has been a huge aid in this effort. What LLMs have very suddenly done is eliminate the need to know how to program to produce useful software. Not all software and not all the time. LLMs still have significant limitations in handling complex software, but a lot of software just isn't that complex. A lot of software is just CRUD apps on a database, and suddenly you don't need a programmer for those. And that's a good thing, because what we were trying to do is not produce software. Software was a means to an end, to providing information for better decisions. If you don't need software to do that, then that's what we were trying to do the whole time. It is an enormous leap forward towards that goal. But of course, vibe coding doesn't eliminate programmers. You still need them for complicated software, at least until LLMs get way, way better than they are. What they do right now is they produce new programmers because vibe coders build simple software, and that simple software becomes more complicated until eventually they can't vibe code their way through it anymore. And then they have to fall back to actual coding. But it gets them really far along the way and dramatically accelerates their journey into coding. That is a huge boost to the accessibility of software development for everybody. But all of this comes with some baggage, and that baggage is legitimate and worth discussing. AI is trained on enormous amounts of data, and it has become clear that the model providers have adopted a beg forgiveness rather than ask permission approach as to where exactly they got all that data. This has tremendous ethical implications and legal implications as well, that I don't have time to get into, but we absolutely need to acknowledge. AI also raises environmental questions. You have probably heard an often repeated talking point that every AI query uses like a bottle of water or something, which is in fact bullshit. It does not pass the LAF test. The average AI query uses 0.26 milliliters of water, which is about 5 drops. That's still a lot of water, especially when you have billions of queries, but it is not some weird water sucking machine. What AI uses a lot of is electricity, which can also use up water. Using radically more electricity to solve problems is good. Using it to violate artists' copyright is bad. That's my basic take. AI is also causing enormous economic turmoil. If you haven't looked at the job market recently, then congratulations, because it is a mess out there. Candidates are using AI to generate hundreds of resumes tailored to each job and apply to all of them at once. This creates thousands of applicants for every job. So, in defense, the people who are doing the hiring start using AI to screen applicants as well. AI meets AI in a battle of hallucinations that makes it very hard to get hired. AI is also automating a lot of jobs, which so far is not eliminating jobs in huge numbers, or at least that's what the data says. But it is possibly making existing jobs more efficient, which is slowing hiring of additional people, especially junior folks. It's making entry-level jobs more hard to get. Nevertheless, my take is that the trend is good. We will figure these problems out, and the payoff is a huge leap forward. Democratizing access to information is the dream. Unlocking non-developers to create software is the dream. Turning more people into developers is the dream. And maybe it's your mission as well. It has certainly been my mission for a very long time. So after that philosophical digression into the nature of AI and the value of accessibility in programming and whether vibe coding is the future, let's get back to MCP. If you agree that democratizing access to information is a worthwhile goal, then I hope I've made the case that MCP is an excellent way of doing that. So that brings us from what MCP is to why you should bother with it. Hopefully my thesis is already clear, but let's boil it down. APIs are an excellent way of providing access to data. MCPs are a big step further forward. Instead of making your API easy to code, you can make it so that you can get to the data without needing to do any coding at all. Because vibe coding, I'm here to claim, is a force for good. It's a democratizing force. It is a further push towards accessibility. And if you're sold, then that's great. If you're not sold, well, you can probably stop listening now, because now I'm going to assume you want to do MCP, and I'm going to talk about how to do that. The most important point about MCP is that you do not need to roll your own. The early MCP servers did, and it was very painful, but frameworks are rapidly emerging. Chief among them is FastMCP, which is an implementation of the protocol so good that it is now incorporated into the official MCP SDK. You can skip the whole protocol implementation and just describe and develop your tools. Authentication support is built in, and it's available in both Python and TypeScript. Fast MCP supports authentication, like I said, but if you implement some other way, there is also an MCP auth standalone package that handles the OAuth stuff for you. It is also available in both TypeScript and Python. So there's a bunch of ways to get started. This allows you to focus on building your tools, which, as I mentioned earlier, are not the same as your REST API. You should be exposing tasks, not endpoints. You should consider user journeys and frequently asked questions and try to wrap up a user's entire journey into just a tool call or two. This is not least because AI agents begin to get confused if you give them a whole lot of tools at the same time. In my experience, something like 5 to 7 tools is the maximum number you can give them before your agent begins to get confused about what it should call and in what order. You can incorporate AI agents into your tool responses because that allows you to give them enormous amounts of context about your domain and how to use your API. So start small, think of a single common task, and learn and grow and expand later. Then, once you've got an MCP server, you can become discoverable. There are several ways to do this, but no single canonical way yet, because it's a bit of an emerging part of the standard. There is now an official MCP server registry going, where you can register your server as available. A lot of downstream unofficial registries use this as one of their sources of truth. There's also an emerging proposal for a new well-known endpoint that exposes MCP servers as a file at the root of your server. You can provide this file for agents to discover and pick up. Possibly the most effective thing to do is to provide an llms.txt file at the root of your server. This is not just a way of providing an MCP server, it is a whole human or LLM readable file containing natural language instructions about what data is on your servers, how to access it, such as MCP, and what to do with it. You don't need to implement an MCP server to provide an LLMs.txt today. You can just describe your API, and maybe your agents will be smart enough to figure out how to use it even without MCP. So, what have we talked about today? First, MCP is not rocket science. It is OAuth, it is HTTP, and it is some JSON. Second, MCP enables agents, and agents are the interesting part here. Software that figures out how to solve a problem without needing to be specifically programmed. Third, agents enable vibe coding. Either the agents use MCP directly to get information, or they build software with an MCP client in it to get information. The result is the same. Software gets built that can solve real problems and answer real questions without the user necessarily needing to know how it was done. The result is that humans get access to information and make better decisions for their lives, which is the goal, which is the point. I can't emphasize that enough. I hope this has been a useful little introduction to MCP at the protocol level and what it can do and why it is worth supporting. And thanks very much for your time and attention.